Hello, dear learners. I welcome you all to the online course on domestic equipment maintenance. I am Dr. Bikramjit Goswami from the Department of Electrical and Electronics Engineering, Assam Don Bosco University. So, learners, in this session, we are going to discuss about the inverter and its associated components. It is the first session of the 6th module on inverter and geyser. In the previous module, we have discussed on the microwave oven and water purifier. In today's world, electricity plays a vital role in powering our homes and enabling us to live comfortably with the use of various electrical appliances. However, power outages are a common occurrence in many areas, causing inconvenience, disruption, and potential financial loss. In that case, inverters have emerged as a practical solution to tackle these issues by providing uninterrupted power supply during the blackouts. This session aims to explore the importance, benefits, types, working mechanism, installation process, and impacts of inverters on households. The various internal components, typical problems, operation, and maintenance will also be discussed in detail in the session. With the advances in technology and lifestyle of people, the need for reliable and efficient power sources is felt. One such source is the inverter, which converts DC or direct current power into AC or alternating current power. An inverter consists of three essential components: a battery, a charger, and the inverter itself. The battery supplies the DC power needed to drive the inverter. The charger ensures that the battery is always charged to its maximum capacity, and the inverter converts the DC power into AC power. The battery is the heart of the inverter and provides the DC power that the inverter converts into AC power to power up various devices in the household. Batteries used in home inverters are usually lead-acid batteries that store electrical power in the form of chemical energy. These batteries can be recharged by the inverter whenever the battery level goes below a certain threshold. When the inverter is connected to the mains supply, the charger kicks in and starts charging the battery. However, if the mains supply fails, the battery will provide power to the inverter. The inverter works by first filtering the DC power supplied by the battery, then converting this DC power into AC power using a process called pulse width modulation or PWM. In this process, the inverter increases or decreases the width of each pulse of the DC power, which effectively creates sine waves similar to AC power waves. The output of the inverter is a sinusoidal waveform, which is an essential feature of AC power. This waveform is then used to power various devices in the home, such as lights, fans, TVs, and other electronic appliances. Working mechanism of inverters. Inverters operate through a complex process of converting DC electricity into AC electricity. When the grid power is available from the normal electricity supply, the inverter charges the batteries by converting the AC electricity into DC electricity. During power outages or when the grid fails, the inverter switches its function to convert the DC electricity from the battery into AC electricity, supplying power to the household. Installation process of inverters. Installing an inverter requires careful planning and considerations. Firstly, one needs to assess the power requirements and determine the capacity of the inverter and battery bank required. Next important thing is the placement of the inverter and batteries, which should be in a well ventilated area with proper ventilation to dissipate heat. Finally, the charging mechanism and battery connections must be properly installed, and the inverter must be connected to the home's electrical system. Dear learners, thus we come to the end of the first topic of the session. After going through the basic operation of a home inverter, let us now test our learning by attempting the following questions. After answering these multiple choice questions, let us now move to the next topic of the session, that is to discuss about the internal components of an inverter. Inverters have several internal components that work together to achieve the conversion process from DC to AC. The first internal component is the microcontroller. This is a small computer within the inverter that monitors the DC input voltage. It is responsible for controlling the frequency and the phase of the AC output signal. It also manages the battery charging process, provides protection against overcharging, and prevents over-discharging of the batteries. The microcontroller is the brain of the inverter, and it ensures that the inverter operates smoothly and efficiently. The next internal component of an inverter is the power stage. The power stage consists of two main components, the power transistors and the output filter. The power transistors are responsible for switching the DC input voltage on and off to create the AC output waveform. The output filter is a network of capacitors and inductors that smoothen out the AC signal and reduce any noise or distortion. The power stage is crucial in determining the quality of the AC output waveform. It ensures that the output is clean, stable, and suitable for all types of appliances. Another critical internal component of the inverter is the transformer. This component is responsible for stepping up the voltage to the required level of 230 volt. Finally, the inverter also has various safety components. These components are essential to protect the inverter, the batteries, and the appliances from damage. The safety components include fuses, breakers or MCBs, and sensors that detect any faults or abnormal conditions. For example, if the inverter detects an overload, it will automatically shut down to prevent damage to the appliances and the inverter. The safety components ensure that the inverter functions safely and reliably at all times. The internal components of an inverter are essential to its operation and performance. Each component plays a critical role, from the microcontroller that manages the operation of the inverter to the transformer that steps up the voltage. The power stage ensures that the AC output is clean and suitable for all types of appliances, and the safety components protect against faults and abnormal conditions. Let us now look at some of the common technical problems that may occur in an inverter. The most common technical problems of a home inverter include overload, battery issues, short circuit, and inverter failure. Overload is one of the most common problems faced by homeowners when using an inverter. Overload occurs when the energy demand of appliances connected to the inverter exceeds the total power output it can supply. This can lead to a potential overheating of the inverter, which may cause it to malfunction. To avoid this problem from occurring, it is recommended to connect only the appliances with low power consumption to the inverter at a time. It is also important to ensure that the power rating of the inverter is compatible with the power rating of the appliances it is expected to supply. Another common technical problem faced by inverter users is the battery issues. Over time, the battery of an inverter may become sluggish and unable to store as much power as it used to. This may be due to a number of reasons, such as regular usage and the buildup of sediment. To minimize battery-related issues, it is recommended to maintain a regular check of the battery and replace it once it starts showing signs of weakness. Short circuit, it is also a common technical problem faced by inverter users. This occurs when there is an interruption in the flow of electricity resulting from a poor electrical connection between the inverter and the appliances. Short circuits can cause safety hazards, lead to appliance damage, and possible fire outbreaks. It's important to ensure that electrical connection between appliances and the inverter is strong with no loose ends to avoid short circuits. Lastly, inverter failure is another technical problem that can occur. This may be due to long-term usage of the inverter, power outages, and other system malfunctions. In some cases, inverter failure may be due to a defective component in the inverter, which may cause the system to malfunction. To prevent potential inverter failure, it is important to adhere to regular maintenance and repair procedure of the inverter system. Dear learners, let us now discuss some of the common troubleshooting methods for the common problems that may occur in an inverter. Troubleshooting common problems. No output or power issues. If the home inverter fails to provide any power output, the first step is to check the input power source and battery connections. Ensure that the battery is charged adequately and properly connected to the inverter. If the battery and connection are fine, inspect the fuse or circuit breaker for any tripping or damage. Overheating. Overheating can be a common issue in home inverters due to prolonged use or insufficient ventilation. Check for any obstruction to airflow around the inverter and ensure proper placement in a well-ventilated area. Clean the cooling fans regularly to prevent dust accumulation, which can hinder heat dissipation. Audible alarms or error codes. Many home inverters come equipped with alarm systems or display error codes to indicate specific issues. Refer to the user manual or contact the manufacturer's customer support to understand the meaning of the alarm or error code and troubleshoot accordingly. False tripping or shutdowns. Some inverters may experience false tripping or sudden shutdowns due to overload, short circuits, or excessive voltage fluctuations. Ensure the connected electrical devices or appliances are not exceeding the inverter's rated capacity. If the problem persists, consult a professional electrician to inspect the home's electrical wiring and grounding. Dear learner, after going through the basic internal components and the common technical problems of an inverter, let us now test our learning by attempting the following questions. After answering these multiple choice questions, we now progress ahead to the next topic of the session on inverter maintenance. Maintenance of inverter is very critical to ensure the optimal functioning of the system. Here are some common maintenance steps for a home inverter. The typical steps of inverter maintenance are regular cleaning. Inverters are exposed to dust, dirt, and debris that accumulate over time, thereby blocking the inlet and outlet air passages, which can interfere its cooling process. Regular cleaning of the inverter's external parts using a dry cloth or brush will help remove these particles and prevent overheating, circuit damage, and other problems associated with inverter malfunction. This process should be done every 3 to 6 months. Battery maintenance. Monitor battery health and ensure proper charging. Inspect battery connections, clean terminals, and tighten any loose connections. Keep the battery bank away from extreme temperatures and maintain a suitable charging schedule to prevent overcharging or deep discharging. Maintaining a proper battery fluid level in the inverter is crucial to prolong its lifespan. Inverters primarily rely on batteries to store power that it can convert for use in devices in the house. Therefore, checking the water level in the battery regularly to ensure that it is within the recommended range is crucial. A lower water level reduces the battery's efficiency and, if unchecked, would make the battery fail to charge or discharge properly. Inspecting the cables. The inverter is connected to the battery and other devices in the house through cables. The cables can be prone to damage and wear, especially if they are not properly secured or installed. Inspecting the cables for any breaks or damage and replacing them is necessary. It is a critical maintenance action to ensure that the inverter can transmit power efficiently and safely without posing a risk of electrocution or damage to the devices. Perform a load test. A load test is useful in determining the inverter's ability to supply the required voltage and power to the devices it powers. Often, people assume that their inverters are working correctly, yet the devices are not receiving enough power. A load test will enable you to check if the inverter can handle the essential home appliances such as air conditioners, microwaves, and refrigerators' power needs. Consequently, you can identify any problems early and fix them before they cause more significant issues. Check the earthing connections. Earthing involves providing a pathway for excess electrical current to flow away from the inverter and back to the ground. Proper earthing is essential because it prevents electrical surges that could damage your inverter and other electronics in the house. Checking the earthing connections to ensure that they are correctly installed and functioning is an essential maintenance step. Check the cooling system. Check the cooling fans regularly and clean them to ensure proper airflow and heat dissipation. Malfunctioning fans can lead to overheating and decreased inverter performance. Inspection and testing. Regularly inspect the inverter for any physical damage, loose connections, or worn out components. Test the inverter's functionality by simulating a power outage or checking the battery charging process. In a sense, inverter maintenance is guided by different factors, including the manufacturer's recommendations, the age and frequency of use, and the environment within which they operate. Proper maintenance practices prevent unnecessary expenses and ensure that the inverter operates optimally for an extended duration. Therefore, it is critical to carry out these fundamental maintenance steps to keep your home inverter in good working condition. Dear learner, after going through this topic on the maintenance of inverters, let us now test our learning by attempting the following questions. Okay, dear learners, after attempting these questions, now we come to the conclusion of the session. At the end, I would like to mention that troubleshooting, operation, and maintenance are crucial aspects of ensuring the optimal performance and longevity of inverters. Troubleshooting common problems requires meticulous inspection of power sources, connections, fuses, and error codes. Understanding the operation of home inverters, including key components and their functions, helps in their proper usage and handling. Regular maintenance practices such as cleaning, battery maintenance, cooling system checks, and inspection contribute to the extended lifespan of home inverters. By implementing these practices and seeking professional assistance when needed, households can rely on their home inverters for uninterrupted power backup, enhancing their quality of life and reducing the inconvenience caused by blackouts or power failures. I hope the information given in this video would help you to enhance your knowledge about basics and working of inverter. Thank you.